There's a predator in the ocean that regularly hunts and kills animals nearly its own size, in complete darkness, at depths where sunlight has never once reached. It doesn't do this occasionally. It does this daily, thousands of feet down, using a biological sonar system so powerful it can be felt as physical pressure by anything nearby. Humans have spent more time mapping the surface of Mars than we've spent actually watching this animal hunt. Here's the thing nobody tells you about the sperm whale. Almost everything most people think they know about it comes from one 19th century novel and a handful of surface photographs of something floating peacefully, taking a breath. The actual animal underneath that surface image is one of the most specialized, most physically extreme predators that has ever existed on this planet. Not a gentle giant. A dedicated, efficient, deep ocean killing machine built from the inside out for one specific job. So let's actually go find out what that job looks like, because almost none of it happens anywhere a human being can easily watch. Start with the single, strangest piece of anatomy in the entire animal kingdom, the head. A sperm whale's head makes up roughly a third of its entire body length. And unlike almost every other skull on Earth, most of that space isn't bone. It's a massive oil-filled organ called the spermaceti organ, sitting directly above the whale's actual skull and brain case. 19th century whalers, cutting into it for the first time, assumed the waxy, translucent substance inside was some kind of concentrated reproductive fluid, which is exactly where the name sperm whale comes from. They were completely wrong about what it actually was, and it took modern researchers well over a century to actually work out what that organ is for. Here's the thing, nobody tells you about spermaceti. It isn't decorative, and it isn't fat storage in the way blubber is. Researchers studying sperm whale anatomy, including biologist Kenneth Norris, who spent decades working on cetacean sound production, proposed that the spermaceti organ functions as a precision acoustic lens, an organ purpose-built to focus and direct sound. The whale generates powerful clicks in an air-filled structure near the front of its head, called the museau du singe by early French whalers, and those clicks get reflected backward through the spermaceti organ, off a dense structure at the back of the skull called the frontal air sac, and refocused forward again through a secondary fatty structure called the junk. The entire head, in other words, works less like a face and more like an enormous biological amplifier and directional speaker, purpose-built to throw sound in a tight, aimed beam directly at a target hundreds of meters away in total darkness. Now, here's where it gets genuinely unsettling, because of exactly how loud that beam actually is. Researchers studying sperm whale bioacoustics, notably a team led by marine biologist Peter Madsen, using suction cup hydrophone tags, have recorded sperm whale echolocation clicks reaching source levels of up to around 230 decibels underwater, among the loudest sounds recorded from any living animal on the planet, rivaling or exceeding even blue whale calls in raw intensity, just concentrated into a much tighter beam rather than broadcast in every direction. For comparison, a sound around 150 decibels in air is loud enough to cause immediate physical pain to a human ear. Underwater, at 230 decibels, the sound isn't just loud. Researchers have documented it as functioning as a genuine pressure wave, a physical force capable of being felt, not just heard, by anything caught directly in its path. That detail matters enormously for how sperm whales actually hunt, because it's led to one of the more debated and genuinely disturbing hypotheses in marine biology. The idea that sperm whales might use their clicks not only to locate prey, but to physically stun or debilitate it before ever making contact. Some researchers, following early proposals, sometimes called the Big Bang hypothesis, have suggested that at close range, a concentrated blast of sound at that intensity could disorient or injure soft-bodied prey like squid before the whale's jaws ever close. The hypothesis remains actively debated. Not every researcher agrees the sound itself is powerful enough at typical hunting distances to directly injure prey, and testing it directly, thousands of feet down in total darkness, is exactly as difficult as it sounds. But even the more conservative, broadly accepted interpretation is still remarkable on its own. This is an animal hunting almost entirely by sound, using a weaponized sense organ built directly into the architecture of its own skull. Here's the thing nobody tells you about what that sound is actually used to find, because sperm whales aren't hunting fish the way most predators do. Their primary prey, especially for large adult males, is squid, and not the small variety you'd find near the surface. Sperm whales regularly hunt giant squid, genus Architeuthis, and there is direct physical evidence that they also occasionally take on the even larger, more poorly understood colossal squid, Mesonicoteuthis hamiltoni, an animal that can rival the sperm whale itself in raw mass for its size. That's the wild part. For most of scientific history, nobody had ever seen a giant squid alive in its natural deep-sea habitat. The first confirmed video footage of a live giant squid in the wild wasn't captured until 2004 by a Japanese research team led by Tsunemi Kubodera. And yet marine biologists had known giant squid existed in exact anatomical detail for well over a century, entirely because of sperm whales. Whalers processing sperm whale carcasses routinely found undigested squid beaks in their stomachs, sometimes hundreds at once, along with, far more tellingly, circular sucker scars covering the skin around the whale's head and jaw, sometimes measuring several inches across. Marine biologist Malcolm Clark spent much of his career studying exactly these beak remains recovered from whale stomachs, using them to reconstruct the size, distribution, and abundance of deep-sea squid species that were otherwise essentially unstudyable by any other method. In a very real sense, sperm whales functioned as humanity's only reliable research tool for an entire category of deep ocean life for the better part of 2 centuries, purely because of what was left in their digestive tracts. Now here's where it gets interesting again, because those scars tell a story that goes both directions. A giant squid, even a large one, is not defenseless. Its arms are lined with serrated, chitinous sucker rings, specifically built to grip and tear at exactly this kind of predator. And the scars found on sperm whale skin document genuine, violent combat, not a one-sided slaughter. These are fights that happen in complete darkness, under crushing pressure between 2 animals perfectly evolved to hurt each other, and the only reason humans know these battles happen at all is the physical evidence left carved into a sperm whale's skin afterward. Here's the thing nobody tells you about the environment where all of this actually takes place, because it might be the single most extreme part of the entire story. Sperm whales are, by a significant margin, among the deepest diving mammals on Earth. Researchers using depth recording tags have documented sperm whales diving to depths exceeding 2,000 meters, over 1.25 miles straight down, with some individual dives lasting well over an hour on a single breath. At those depths, water pressure exceeds 200 times what it is at the surface, enough to crush most man-made submersibles without reinforced hulls. To survive repeated dives to that depth, sperm whale physiology has been shaped by a set of adaptations that read almost like a list of engineering solutions to an impossible problem. A genuinely collapsible rib cage that allows the lungs to fold safely under extreme pressure rather than rupture. Blood and muscle tissue saturated with unusually high concentrations of oxygen-storing myoglobin. And a circulatory system capable of selectively redirecting blood flow away from non-essential organs and toward the brain and heart during a dive. This is an animal that spends a significant portion of every single day of its life doing something that would kill an unprotected human being almost instantly, and does it as routine, unremarkable behavior. So picture the actual hunt, stitched together from what tagging studies have recorded. A sperm whale dives, folding its ribs, redirecting its blood flow, descending into total blackness, far below where any sunlight has ever penetrated. Around 1,000 meters down, it begins producing steady, rhythmic echolocation clicks, sweeping a directional beam of sound out into the dark, listening for the returning echo bouncing off something solid in the water ahead. As it closes in on a target, researchers have documented the click rate accelerating dramatically into a rapid buzz, sometimes called a creak, the exact same terminal buzz pattern documented in echolocating bats closing in on flying insects. A universal acoustic signature of a predator zeroing in on the final moment of an attack. Then, in complete darkness at a depth and pressure that would instantly kill an unprotected human, one of the largest predators on the planet closes its jaw around an animal it has never once seen with its eyes. Here's the thing nobody tells you about that jaw, because it's built entirely differently from what most people picture when they imagine a whale's mouth. Sperm whales have functional teeth only in their lower jaw, typically between 18 and 26 of them, each one capable of growing to roughly 8 inches long and weighing up to 2 pounds. The upper jaw has small tooth sockets that the lower teeth fit into when the mouth closes, but those upper teeth rarely fully erupt or serve any real functional purpose. This isn't a weakness. Researchers studying sperm whale feeding behavior have found that the teeth themselves may not even be strictly necessary for successful hunting. Whales with damaged, worn, or in rare cases almost entirely absent lower teeth have still been found in healthy body condition with full stomachs, suggesting the primary killing and capture mechanism may rely far more heavily on suction and the sheer mechanical force of the jaw closing than on the teeth doing precision damage. The bite itself functions less like a scalpel and more like an industrial vice, and that vice is attached to one of the most powerful jaw musculature systems of any living predator. Here's the thing nobody tells you about a second entirely unrelated substance sperm whales produce, one that ended up shaping human economic history almost as strangely as spermaceti did. Roughly 1 in every 100 sperm whales carries, somewhere in its digestive tract, a rare, waxy secretion known as ambergris. believed to form around undigested squid beaks as a kind of protective intestinal buffer. For centuries, sailors had no idea what it actually was or where it came from, only that lumps of it occasionally washed up on beaches or turned up floating at sea, and that it was worth an extraordinary amount of money. Once it ages and oxidizes in seawater, ambergris develops a genuinely prized, complex scent, and it became one of the most valuable substances in the historical perfume industry, sometimes literally worth more per ounce than gold. An animal built around a weaponized sound organ in its skull was also, almost as a side effect of digesting armored squid beaks, quietly manufacturing one of the most sought-after luxury materials in human history entirely by accident and largely misunderstood by the very people profiting from it for the better part of 2 centuries. That confusion and that profit is exactly what turned this animal into the primary target of one of the largest, most brutal extraction industries in human history. Spermaceti oil, drained directly from that acoustic organ in the whale's skull, burned cleaner and brighter than most other available oils. And by the 18th and 19th centuries, it had become the preferred fuel for high-quality lamps and an essential lubricant for precision machinery across Europe and North America. Entire regional economies, most famously in Nantucket and New Bedford, Massachusetts, were built almost entirely around hunting this one specific animal for the contents of its head. Multi-year whaling voyages, tracking sperm whale migration routes across literally every ocean on Earth, became genuinely massive industrial operations. And by some historical population estimates, commercial whaling reduced global sperm whale numbers by more than half before the practice was finally banned by international moratorium in the 1980s. The same acoustic organ that makes a sperm whale one of the most capable hunters in the deep ocean is, unsettlingly, the exact reason humans hunted it to the edge of its own population collapse. Now here's where the story turns towards something even the sperm whale doesn't fully control: its own reputation, built almost entirely on documented violence against something it was never evolved to encounter: ships. On November 20th, 1820, the American whaling ship Essex, hunting in the South Pacific, was struck twice by a large bull sperm whale, an animal first mate Owen Chase, who survived the encounter and later published a detailed written account, described as moving with obvious deliberate purpose rather than random panic. The whale's second strike, delivered directly to the bow at speed, staved in the ship's hull and sank it outright, leaving the surviving crew adrift in small whaleboats for months, in one of the most harrowing survival accounts in maritime history. Herman Melville read Chase's first-hand account years later and used it as the direct factual seed for the climax of Moby-Dick. The Essex wasn't an isolated incident either. In 1851, another American whaling ship, the Anne Alexander, was similarly rammed and sunk by a sperm whale during an active hunt, an animal that, according to surviving accounts, turned directly toward the ship after being wounded rather than fleeing the way whalers generally expected prey to behave. Here's the thing nobody tells you about why that behavior is actually significant, beyond just being a dramatic story. A wooden whaling ship of that era was not a small object, and turning to ram one twice with enough force to breach reinforced hull planking required an animal both physically capable of generating that kind of impact force and, by multiple first-hand accounts, apparently deliberate about doing it. Whether that behavior reflects genuine strategic problem-solving under attack, simple defensive aggression, or some combination the historical record can't fully resolve, it happened often enough, and was documented specifically and consistently enough across multiple unrelated incidents that 19th century whalers developed a very real, very practical fear of sperm whales, specifically fighting back. A fear entirely absent from how they discussed most other whale species they hunted. That's the wild part, and it connects directly back to the brain doing all of this calculating in the first place. Sperm whales possess the largest brain of any animal known to have ever existed on Earth, living or extinct, averaging around 18 pounds, roughly 5 times heavier than an adult human brain. Raw brain size alone doesn't automatically equate to raw intelligence, brain-to-body ratio, and internal structure. Both matter enormously, and researchers are still working out exactly how sperm whale cognition compares functionally to other highly intelligent species. But sperm whales are also deeply, observably social animals, living in stable, long-term matrilineal family units, communicating using patterned sequences of clicks called codas that function almost like regional dialects, distinct enough between different social clans that researchers, including longtime sperm whale researcher Hal Whitehead at Dalhousie University, have spent decades documenting and cataloging them as something closely resembling distinct cultural traditions passed down through related family groups. Those codas turn out to carry more structure than a simple alarm call or contact signal. Whitehead's long-term research, along with more recent work using machine learning analysis of large recorded coda datasets, has identified what researchers describe as a kind of combinatorial structure within sperm whale click sequences. Individual clicks combining into distinct patterned codas, the way letters combine into words with identifiably different dialects used consistently by different family clans, occupying overlapping ocean territory without ever mixing socially. Calves are not born already knowing their clan's specific coda patterns. They learn them over time from the adults around them, the same basic mechanism underlying vocal learning and cultural transmission in humans. It's still genuinely disputed among researchers exactly how close this comes to anything resembling human language, and drawing that comparison too directly risks overstating what's actually been confirmed. But at minimum, it represents a documented, learned, socially transmitted communication system passed down within family lines, which is a genuinely rare thing to find anywhere outside our own species. Here's the thing, nobody tells you about how that social structure connects directly to survival. Because sperm whales aren't just intelligent in isolation, they're intelligent together, and it shows most clearly in how they defend each other. Orcas, the ocean's other reigning apex predator, are one of the only animals that will actively attempt to prey on sperm whales, typically targeting calves or vulnerable individuals within a pod. When threatened, sperm whales have been documented forming a defensive configuration researchers call the Marguerite formation, arranging themselves in a tight circle with their heads pointed inward and their powerful tail flukes facing outward toward the threat, protecting vulnerable calves at the center while presenting a ring of their single most damaging weapon to any attacker approaching from any direction. It's a coordinated, learned defensive behavior, not blind instinct, and orca pods attempting to break through a properly formed Marguerite formation have been documented failing to successfully take a calf in multiple observed encounters. So put all of this together, piece by piece, and the actual picture that emerges looks almost nothing like the version of this animal most people carry around in their heads. A skull architecturally rebuilt around a directional acoustic weapon capable of producing some of the most intense sound documented in the animal kingdom. A hunting method that regularly targets some of the largest, least understood predators in the deep ocean, in total darkness, at depths that would instantly kill an unprotected human being. A documented, repeated willingness to turn and fight back against the single most dangerous predator this planet has ever produced, us, with enough physical force to sink full-sized wooden ships. And underneath all of it, the largest brain ever measured in a living animal, organizing complex social bonds, regional cultural dialects, and coordinated group defense strategies sophisticated enough to actively repel attacks from orcas. None of that fits comfortably into gentle giant. It also doesn't fit neatly into mindless monster, which is exactly the trap Moby-Dick, as brilliant as it is, quietly set for nearly 2 centuries of popular imagination. The real animal is something stranger and considerably more impressive than either caricature. A predator so specifically, thoroughly optimized for total darkness and crushing pressure that it built an entirely separate sensory world for itself, one most of the ocean's other predators can't even perceive, let alone compete inside of. So picture it one final time. 1,000 meters down, in absolute blackness, in cold that would stop a human heart within minutes and pressure that would collapse an unreinforced hull. Something the length of a school bus is moving through that darkness with total, practiced confidence, clicking steadily into the void, reading the echoes bouncing back with a precision no human instrument fully matches even today. Somewhere ahead of it, an animal nearly its own size is about to lose a fight it never saw coming, in the truest, most literal sense possible, because down here, nothing sees anything coming. Down here, everything simply listens for it.